Hi, and welcome to S for Science. And is the Earth hollow? You may answer that it is or that it is not. But whatever you answer me, I am going to ask you to justify it. And this may be more difficult to you than to simply affirm that it is or that it is not. So in this video, we're going to do science, and we're going to consider one of the two hypotheses to load ourselves with arguments and demonstrate if it really is or not. So, what would happen if the Earth was hollow? Before starting, it is important to note that there are several possible configurations of this hypothesis, going through a completely hollow Earth to an Earth in a form of different layers with spaces between them. And the most famous one, where the Earth, in addition to being hollow, has a sun or a black hole inside of it. Okay, it's time to imagine. For a moment, whatever you believe in, imagine that indeed, the Earth is hollow. Now take any object and throw it into the air. Effectively, it falls. This is because gravity is exerting a force on this object. More specifically, this force is being created by a quantity of matter. And even more specifically, this quantity of matter is in the direction in which the object falls. And thanks to this, we can calculate how much matter is below. That is, how much matter is causing this object to fall. And you can do it at home. You just need a piece of paper and a pencil to do the calculations, an object that does not have much aerodynamic resistance, and a precise chronometer. And then, just throw the object from a known height and measure how long it takes to fall. Then we apply the acceleration formula that never lies, and we find the famous value of gravity. What we have found in this home experiment, as we said before, is an acceleration. This means that any object that is falling will fall faster and faster. And this increase in speed, this acceleration, is caused by the object that causes gravity. This is why, for example, to take off from the moon, only a small vehicle is needed, compared to the rocket that is needed to leave the Earth. But let's go back to our hollow Earth. 9.8 meters per second, or the value that you have come up with, which if you have done more or less well will be close to this. Let's now use the formula of the universal law of gravitation and calculate the mass of the body that exerts gravity that we have calculated at home and that we experience every single day. In this formula, F is the force of gravity and G is the universal gravitational constant, a number that is the same anywhere in the universe, and that was obtained experimentally. We get more or less a value of 5.9 times 10 to the power of 24 kilograms. So, if the Earth was hollow, all this mass would be in the thin layer that separates the empty interior from the surface. What density would this layer need to have? Well, if we assume that the layer would be about 10 kilometers thick, which is already a lot, and we divide the mass that we have obtained by the volume that this layer would have, applying the formula that we all know about density, the result will be that the density would have to be 1,940 kilograms per cubic centimeter. That means that each cubic centimeter of the material that we have under our feet should weigh 1,940 kilograms, which is impossible. There are many mines on Earth that have drilled significant depths and have not found a material of this extreme density. Mines that you can visit and see for yourself, and you'll see that there's no materials of this density. In fact, this density would be in the order of magnitude of the density that black holes have. Seems hard to believe, but not impossible. Okay, we have ruled out the existence of this super dense outer layer, but since we have talked about black holes, since obviously the outer layer couldn't be made out of black holes, couldn't it be that inside the hollow Earth there was a black hole that exerted the necessary gravity? No, this is what a black hole does. You can go to any observatory and see what these monsters of the universe do, that destroy absolutely everything that gets in their way. There is no material anywhere near strong enough to resist the gravity that a black hole would exert on it. A layer as thin as the Earth would have would quickly break apart. The only way that the layer could hold up would be if there was an enormous tensile force that held up the entire outer layer together. And there is no material strong enough to exert this force. But what if instead of imagining a black hole, we imagine a sun inside of the hollow Earth? Well, this is impossible, because the smallest possible star has to be at least a little bit larger than Jupiter. And obviously that wouldn't fit on Earth. Besides, it wouldn't exert the gravity that we had calculated before. We have obtained the limit of the size of the stars from the physical laws that accurately predict how matter behaves. If we point our telescopes to the sky, we'll indeed not find any star smaller than Jupiter. This is because fusion simply does not occur in such small bodies, and the largest planet in the solar system is a good proof of this. Hollow Earth hypothesis ruled out. Or maybe not. Because if we imagine that at the base of the shell of the Earth, there was a cable made of a material resistant enough to support that structure, it would be strange, not to say impossible, for that to exist, and not to say that it will also be strange for that to be placed there magically in order to hold the Earth. But let's also consider that option. Could it validate the Hollow Earth hypothesis? Well, here we find some problems. The first of which being, where does the lava from volcanoes come from? In a Hollow Earth model, those voluminous amounts of lava that emerge from the surface would not have a possible origin. They would simply fall towards the black hole, or if the Earth was completely hollow, they would remain floating in the middle of that vacuum, as there would be no gravity inside due to the fact that any body inside of the Earth would feel the same attraction to any point of it. And let's not forget the heat. The lava that emanates from volcanoes reaches temperatures above 1000 degrees, heat that, according to the non-hollow Earth model, could be preserved since the planet was formed, thanks to the fact that as there is more mass, less energy is dispersed, energy that has been lost over time, and indeed, our Earth is much colder than when it was formed. But according to the Hollow Earth model, this heat would have been dispersed completely in a few centuries, and everything would be cold down there. But we still have one last problem to solve, the biggest of all. And that problem, that was actually the solution to knowing what we really have under our feet. It's called seismicity. When an earthquake occurs, great amounts of energy are released. That is released in the form of seismic waves. What is also interesting is that different types of waves are released, up to 5 different types. Something that can be verified near any place where an earthquake occurs. But we're going to focus on the two most interesting waves, the primary and secondary waves, also called respectively P waves and S waves. It's known and has also been demonstrated that P waves only propagate through liquid matter and solid matter. It's also known that S waves only propagate through solid matter. And it's also known that neither of them propagate through air or the void. And you will wonder, what those waves have to do with the hollow Earth? Well, let me explain. When a major earthquake occurs somewhere in the world, stations with seismic wave detectors located on the opposite side of the planet detect P waves. Waves that have no nearby origin since there has not been any earthquake near those stations. Even more so, the pattern of those waves is very similar to that detected by seismic waves that were close to the origin of the earthquake. Then what's the origin of those waves? The earthquake that occurred just in the Antipodes. The waves travel through the Earth to the station. And let's remember that these waves need a solid body to propagate. And the most interesting thing is that a shadow zone of the S waves is observed, the ones that can't go through liquids. Thanks to this, we know that the outer core of the Earth is liquid, since it does not allow the waves themselves to pass through it. Only P waves go through. You may think that the seismic wave model works equally well in a hollow Earth, because P and S waves could travel through the shell of the Earth and end up arriving at the seismic station. However, this is not the case, because we know at what speeds these waves move. And if they have to go through the shell of the Earth, they would take much longer than what it takes in a straight line. And they take what it would take if they were going in a straight line. So every time there's an earthquake, it is demonstrated again conclusively that the Earth is not hollow, nor that it has a sun or a black hole inside of it, nor that it's made of layers of air. If you want to verify it, all you have to do is to wait for a big earthquake and go to one of your nearest seismic stations and wait there for the waves. They'll arrive sooner or later. And there we have it. Through the scientific method, we have ruled out a hypothesis. We did not know at first if it was true or not, but applying our experiments and observations, we ended up having to rule out that hypothesis. So instead of calling it the Hollow Earth theory, from now on we should call it the discarded hypothesis of the Hollow Earth. With this video, we have seen the importance of verifying everything that we think we know about the functioning of the universe. The importance of not letting ourselves be carried away by what seems more ideal, easier to assimilate, or by what seems more real. Because with the times that are coming, there will be more and more information available around the world. And in parallel, there will be more and more doubts about what is true and what is not. The new science with quantum physics and astronomy is going to be something more counterintuitive than we could expect. So it will be very important that we all do a good job on interpretation of this valuable information that will give us the keys to understand our universe. We'll have to decide what to do with those keys. It will be in our hands to decide to open the correct door. Thank you very much for watching the video, and goodbye.